Well, I invite you to the next lecture in the BIM Basic series. Last time we talked about the limitations of traditional construction and the evolution of CAD techniques toward BIM. Today we will discuss the basic definitions related to BIM. We will start with an introduction to the BIM methodology with basic definitions. We'll present the BIM maturity levels and compare CAD techniques with the BIM methodology. Then we will discuss the benefits of using BIM. Finally, it will be brief about the data exchange platform, which is called CDE, Common Data Environment. We start with an introduction to the BIM methodology. So, what is the abbreviation BIM so often used here? Many different definitions can be found in the literature. Referring to more popular sources like Wikipedia, we will find out that this is building information modeling, where the models represents a digitally recorded representation of the physical and functional properties of a building object. There are also less precise descriptions that treat BIM as a tool to improve the design and construction process. Most often, however, uh, we are talking about computer BIM technology in which they are dealing with an IT model, and it is object oriented. As a result, these model can be can somehow coexist with a real object and can be subjected even to similar processes. We have already seen these photos. They show that in civil engineering we have an exceptionally large number of unresolved issues. They can be bestowed on almost all the research areas and disciplines. Mm, we need new materials and technological solutions, automation and robotization, new design and modeling methods, better methods of construction management and organization, processing of enormous data in the field of managing huge resources in the form of many different structures, and more efficient diagnostic methods, the results of which will feed the models of degradation and individual objects, individual buildings, extending the life cycle. Well, the European Directive on Public Procurement, published in 2014, will, in my opinion, radically change the entire construction market. It proposed the use of the so-called electronic building data modeling tools. It was not stated explicitly, but it should be understood that this tool is BIM, understood as building information modeling. According to the intention of the European Commission, the implementation of BIM will allow, among others, of course, to optimize the planning and implementation of public investments. All this is expected to lead to savings up to 20%. These are, of course, politicians' estimates, and I really don't want to verify them here. However, we need to know that countries such as the United Kingdom, the Netherlands, and the whole of Scandinavia have introduced mandatory BIM in all public procurement since 2016. The implementation of this directive is also already included in our new Act on Public Procurement, although the use of BIM is not yet mandatory there. When creating the three-dimensional geometry of a building model, primitives that were used in CAD programs, an example, a line, circle, or even cylindrical and cuboid solids. They are not no longer used, but parametric and intelligent objects such as wall, column, window, that more objects are used. Bar, profile, tendon, etc. They are stored in a semantic data structures. These objects are given appropriate parameters and made dependent on the general axial or geometric system of the entire structure. In addition to the geometry of the building's beam model shown in this picture, it can store a number of other, sometimes very different types of data, such as material and cost data, information on installation time and technology, facility equipment with operating instructions and guarantees, detected damage and history, repair or modification. It can also be used to simulate changes in various functional parameters of an object, like heating, ventilation, lighting, engaged, or even to control these parameters interactively, like we know from smart structure. Importantly, the model maintains defined relationships and dependencies between individual components. The column indicated here will react with a change in the height when you decide to change the position of the ceiling. On the other hand, an example, a window can be inserted only into the wall, not into the foundation, and in turn, moving the wall will move the window as well. The BIM approach is based on creating an object database of information about a building and specifying the data and methods of operating on its elements. Instead of lines and curves, more complex objects, more complex object elements such as beam, column, frame are available. An example of the data structure describing the objects in the category of columns is presented on this figure. On each of these elements, we can perform a different type of related operation, such as moving, stretching on, or, or reinforcing the element, if we have a reinforced concrete element, column or a beam. The software allows us to create our own object containing relevant data. Unfortunately, the ability to define our own operations on objects is still remains limited. There is a lot of misunderstanding about BIM. Um, Above all, it should be remembered that BIM is not just an extension of CAD techniques to 3D space. It allows to improve the entire process of investment, implementation, and even the use of the facility. At most, CAD can be a subset of BIM that improves drawing performance. I'd like to point out that the most important word in the BIM cluster and the BIM shortcut is information. As you can see here, the BIM methodology has many application areas in the implementation of construction investments. Having a BIM model, you can perform various analyses and calculations, create bills of materials, show execution details, automatically generate flat drawings, 2D drawings with plans and sections, support project management and the finished building. And even the visualization, the rendering are only a byproduct of having a BIM model. One model can be used by various cooperating industries. Architects, builders, and various installers must and can finally collaborate with each other. This has never been successfully accomplished with CAD techniques and tools. In BIM technology, this collaboration is the starting point of creating new software. Unfortunately, the word collaboration has a bad connotation in Polish language, while in my generation it is associated with collaboration with the communists during the communistic time of Poland, or with the German occupier during the Second World War. Um, may the new generations no longer have such experiences. So we have the opportunity to work on one model in a multidisciplinary team, which was extremely difficult in CAD techniques. Additionally, it can be done at all stages of the investment. The, the literature often points to the multidimensionality of BIM models, which is treated symbolically and conventionally. Uh, it results from the possibilities that these IT models hide. How should this be understood? Well, 3D is really just geometry itself. The fourth dimension is time, understood as schedules. The next dimensions are very conventional. So we have 5D, which means costs, and 6D and 7D, which relate to facility management in general. The 6D dimension is durability, energy consumption, and emission. An example, carbon footprint. On the other hand, 7D is usually the use of the BIM model and processes to manage an already built facility. That is support for the owner or administrator of the building, collection of data from inspection and modernization, modeling the degradation process, planning repairs, but also the project of demolition and decommissioning of the facility. The literature often points to the multidimensionality of BIM models. Interestingly, this multidimensionality can be differently understood and used in at different stages of the building of the facility's life cycle. So, for example, at the design stage, 3D geometry will be used to create takeoffs, and in the maintenance process, it will be a knowledge base about the materials used for construction and the equipment installed. The 4D the 4D model is in design and construction means delivery schedules and logistics. And in maintenance, it is maintenance of in operation time. It is maintenance and repair planning. This multidimensionality is, as I said, very much a deal between the parts, between the users. There are no norm standards of these, and dimensions above the fifth are understood in different ways and frequently changed. Perhaps we'll see some standardization here one day. For now, however, we can see that there are ideas for further developing these dimensions. Here we can see the beam 8D, which according to the authors of this idea would be related to safety issues. For example, health and safety on construction site or even in operation time. The BIM methodology also uses variable levels of detail for BIM models. They are well defined and illustrated by examples. They guarantee at each stage of the project implementation a sufficient minimum amount of information in BIM models, which is necessary for the evaluation and approval of the proposed solutions by the contracting authority. Thanks to this, it can be done without the design and executive teams incurring an excessive workload related to unnecessary detailed modeling at a given stage. This approach is consistent with the idea of lean construction. It allows to eliminate losses resulting from too great saturation with information. The B model can be used throughout the life cycle of the building, from initial planning and design through implementation and commissioning, then in the maintenance operation process, renovation and reconstruction, to demolition and decommissioning. All this time, we feed the model with new information that is generated throughout the life cycle. This issue of linking the B model with the building life cycle is still at the stage of research and initial development. Thus, in the literature, there are such graphs showing various stages of the life cycle and then the processes and activities occurring in them. It will certainly depend on the type and function of the building. It will be different with a gazebo in the park or a shelter above the gas station. You can you can distinguish other stages at the single family house and other stages at the multi-story apartment building or office building. It will be different yet with the highways or bridges where we have much longer life cycles and these objects are not subject to the market game related to their turnover on the real estate market. Even the standards already explicitly mention the link between BIM models and the life cycle of buildings. After all, construction investments do not only serve to design or build something. We undertake all these efforts for a different and high purpose. An investor who decides to make a new investment meets his economic needs in this way. At the same time, he must strive to maximize the profits from his investment. As a result of its implementation, it acquires new assets, which must then manage wisely in order to maximize profits again. In a word, the most important thing is the economic calculation, the economic result. Therefore, the series of ISO management standards presented here uh, is consistent in terms of organization, assets, and building information management throughout all stages of the building lifecycle. Thus, it distinguishes between the design and construction phases and the operation phase. They are accompanied by properly defined B model, which are called PIM and AIM, respectively. I will tell you more about this when discussing issues in the field of asset management. BIM methodology is always accompanied by the so-called Common, Data Exchange platform, abbreviated as CDE. The CDE platform is usually specialized software that allows access to design documentation with B models to all authorized participants of the construction process and is used to improve communication between them. Thus, we have three main areas of use of CDE related to the description of space in, for example, geometry, design documentation and construction documents, as well as data collected throughout the life cycle of a building and processed between participants in the construction process. The main benefits of using BIM technology are the effective acquisition and management of information throughout the life cycle of a building facility. The flow of this information is much more structured than in the traditional approach, which use documentation created with CAD technique. BIM, however, is not only a 3D model, but also all the necessary information that can improve the design, implementation, operation, renovation, or modernization of a building object. This information is thus easily accessible to authorized entities. They are also constantly updated and easily interpreted by everyone, especially in the case of automation and robotization. After all, computers and robots cannot interpret paper documentations, drawings, and it's recorded in the form of digital models in natural. The relationships between the participants in the construction process are already much more centralized and related to the changing BIM model of the building. Before, they were very chaotic and direct. The rest of the team members or process participants were often unaware of the events or decisions made. These later had disastrous consequences for investment costs or meeting the deadline. BIM technology is primarily teamwork and the need to cooperate with other teams. The models built are very larger. The models are built are ever larger and more interdisciplinary and multi-threaded. This, of course, will force over ever greater needs in terms of the capabilities of our hardware and the amount of available memory, processing speed, transmission, and display, as well as software capabilities. In general, the modern world is about working in a harmonious team. Therefore, it is less important for employees today that our graduates have terabytes of specialist knowledge loaded in their heads, um, and that they appreciate creativity and teamwork much more. Now let's see what B maturity levels are. In many publications, the diagram shown here shows the maturity levels of BIM. In a way of the evolution of CAD systems towards BIM discussed earlier. The first phase, level 0, is unmanaged development in any way. Even computer-aided CAD tools, but only with 2D graphics. For these, drawing and text with paper or electronic information exchange, but without common standards and processes. It is essentially a digital drawing board that, and that's how CAD tools are actually used today. But it is also a BIM, of course, it is BIM, but at the zero level, where the information is only in the form of paper documentation. The next phase, level 1, introduces management elements to CAD tools. Spatial coordination and standardized structures and formats are emerging increasingly close to BIM Level 2 standards. These may include not only 2D but also 3D information. Most often, however, only for visualization or concept development. This phase is sometimes referred to as solitary BIM because the models are not shared among the members of the project team. The transition from phase 1 to 2 began as better and better 3D modeling tools began to be used to design more advanced and sophisticated building forms. As in the engineering industry, it quickly became apparent that 3D tools were no longer sufficient for modeling complex building objects. It was especially visible after the advent of parametric design, which allowed for modeling more complex shapes, remembering the history of model creation and the repeatability of certain sequences and easy editing by changing a previously defined parameter. Since the first primitive 3D programs, the use of the third dimension has been improved so much that it is relatively easy to reproduce almost any shape of a building, and the projections and the section need to create a paper documentation can be generated almost automatically. The next phase, level 2, includes a managed 3D environment with attached data, but created in separate models by each design industry. These separate models can be combined together to form a related model, but they do not lose their identity or integrity. The data may include information on how the structure was assembled, that's the BIM 4D, and on costs as well, that's the 5D BIM. This is sometimes referred to as a proprietary BIM or in a shortcut PBIM. The UK government's in construction development strategy states that the government will require full BIM 3D interoperability with all electronic project and asset information, documentation and data. It is therefore the minimum BIM requirements of level 2 for UK public projects. The last phase, level 3, is one common project model available to all participants of the investment process directly and in a real time with scheduling, BIM 4D, bills of quantities and cost estimates, BIM 5D, energy analysis, BIM 6D, and information about the facilities, about the assets in the life cycle, that's the 7D. This level sometimes referred to as an integrated BIM, in the shortcut IBIM, allows us to get better business outcomes for the entire investment. Since such integration concerns the entire project team and other participants in the construction process, it forces a change in work organization. Teams begin to work closely together, and it is much more important to exchange information effectively. Consequently, there is a need to create new positions and competences, such as a BIM manager or an information manager. Achieving this last phase is a long-term task, of course, but that many of the world's most developed countries have set for themselves. It is about developing a fully functional BIM model for managing the entire life cycle of a building. The PLM, product lifecycle management. In industry, it is a process of managing the entire life cycle of a product, from its inception through design and engineering production to service and disposal. In a broader sense, this obviously refers to the stages of the product life cycle, which are already deeply rooted in the economy and industry, and even their management methods. When a construction object is treated as a product in construction, it is the process of managing the entire life cycle of a building, from planning, designing, and construction to use and maintenance to demolition and decommissioning. The BIM model, by integrating data from various sources about the object, can therefore be used as a database throughout the entire life cycle of the building. Thus, it will be the best tool to support building life cycle management. IPD, Integrated Project Delivery, is a completely new concept for the implementation of a construction project developed by the American Institute of Architects. It aims to integrate people, systems, business structures, and practices into a process that uses the talents and knowledge of all participants. All these optimize the results of the investment project, increase the value of the facility for the contracting authority, reduce waste, and maximize efficiency at all stages of design, production, and construction. The greatest strength of IPD is the ability to work out compromises and work in accordance with clearly defined rules of the game when conducting investments. The strongest points of all players are used in this process. IPD is very closely related to the BIM methodology because without it, the IPD approach is practically impossible to implement. In a traditional investment process, a lot of information is lost many times, which must entail certain costs. In this drawing, in this graph, I have illustrated the recurring necessity and loss of information at various stages of a building's life. The names of these stages and their number should be treated arbitrarily, and their selection in this case results rather from the intensity of the information flow. The related additional costs may relate to reconstructing the necessary information at the next stage, bad decisions resulting from incomplete or incorrect information, design, assembly, and logistics collisions, delays in implementation, excessive amounts of waste and excess stocks, social and environmental effects. So let's now compare traditional CAD techniques and BIM methodology. First, when creating project documentation in CAD technique, the view drawings of each element are created separately and there is no direct connection between them. Therefore, changes to each view must be updated manually. However, editing these separate drawings is therefore lengthy and difficult. We often have to make similar changes repeatedly on subsequent views or sections. In the case of the BIM methodology, views and sections are actually generated automatically based on the BIM model. There is a full relationship between the drawing generated in this way. Model changes update automatically uh, generated views. This makes editing drawings much faster and easier. In both cases, we use certain primitives, libraries of repetitive elements in the form of blocks, like in CAD techniques, or families that we deal with the BIM methodology. A CAD drawing consists of drawing primitives such as lines, curves, circles, tanks, shapes, surfaces, etc., solids as well. Now, thus, they can be freely interpreted by the designer, and their purpose is only contractual. A rectangle in the drawing may represent a beam section or a wall opening. It can be the outline of a ceiling or a wall. Um, in addition, other industries reading this drawing will interpret this rectangle in a different way. This is highly contractual, and not all of them have to be structural engineers. In the case of BIM, the building model already consists of intelligent objects, instead of drawings, blocks known from CAD. We have families that have a specific interpretation at the time of creation. It can be a beam, column, foundation, railing, etc. In the column family, we can create new columns that inherit certain properties depending on whether they will be steel or reinforced concrete columns. These families are integrally related to the modeled element and object. They also enter into relationships with the surrounding objects. The objects used to create a model are very different between the two approaches. As I said, in CAD, they are very contractual and can be interpreted differently. In BIM, 3D objects have properties that are characteristic of the modeled element. They will be different for concrete elements and different for timber ones. Importantly, mm, they can be edited, affecting their appearance and relations with other objects. Even greater differences exist when modeling construction processes and introducing changes to the site. In CAD techniques, it is practically impossible to save information related to the construction process on the drawing. Design changes can only be taken into account when creating as-built documentation. This is done by introducing red lines and comments on the original paper documentation. This again can be interpreted differently and ambiguously. Meanwhile, the B model reflects the real object. It can and should be modified on an ongoing basis during construction. It can also record the history of changes and even who made them. Information is not only graphics, but above all, numerous non-graphical data that are present in every construction investment. In the CAD technique, we again use primitives in the form of texts or labels, blocks with attributes, for example. These main carriers of non-graphic information are usually not associated with graphic objects. Graphical objects in a BIM model are also inherently store non-graphical data. Therefore, they can be used to generate descriptions, summaries, bills of quantities, and different analyses. Typically, there is an association between data types. We have already talked about multidiscipline. CAD drawings pass from one industry to another. Designers, in fact, they work independently of each other, and it is not possible to track changes on the fly. Sharing CAD drawings has never been efficient or convenient enough. However, the B model is available to all industries from the very beginning. Designers build it together and complement it. Of course, in the area made available to them, which results from the privileges. It is also possible to track changes and search for collisions between industries. The differences in CAD and BIM approach are best seen in these charts showing the so-called MacLeamy curves. You can see the impact of the changes in the design on the final cost of the investment in comparison with the involvement of the designers. We know that creating a 3D model in the BIM approach will require much more involvement from the designer, much more time. The design cost will certainly be higher and the project delivery time may be longer. Only if it really is ultimately disadvantageous. We will see. So we can see that in the BIM approach, that's the green line, the greatest time consumption occurs rather in the initial phases, especially with a construction project. It is more effective to work with a model later. In the CAD approach, that's the blue line, we quickly prepare simple documentation and the concept stage, and the greatest time consuming factor is when creating documentation already at the detailed design stage. So practically already during the works in the field, in the construction site. And how does these translate into investment costs? This is shown in turn by the red curve. Of course, any changes to the project generate additional costs. And as you can see, they will be at the highest when there is a need to modify the already made elements. This shows why in the CAD approach, the most frequently used tool for document correction is the proverbial jackhammer. And, and here also shows the advantage of the BIM approach. An important element of introducing BIM is also a qualitative change in the work of designers. Well, instead of producing documentation, they can finally focus on design. Being the first element of the BIM chain, they have a huge impact on the final result. The impact of design expenditures on the cost of road and bridge investment can be seen in these two charts. They were prepared on the basis of data from the USA. Although the expenditure on bridge and road design varies considerably due to the higher complexity of bridge project, the impact of the project on the final financial result of the investment is crucial for both types of facilities. Of course, this does not mean that high remuneration for designers will be a guarantee of a good design and lower costs of the entire investment. But surely, a good planning of the entire project budget will allow us to allocate resources in such a way as to obtain the best end result. You can see that as design costs decrease, construction costs increase. Therefore, procuring entities should treat project costs also as investment in future budget control of the investment, and not only as a component of the facility's lifecycle cost. Although, of course, further increasing the remuneration for the project doesn't bring such a noticeable effect. I will now present the benefits we have thanks to the use of the BIM methodology. The benefits of using BIM are often said. Most of you probably um, equate BIM with new design tools, um, but they are also tools to improve construction processes and operation and maintenance of existing facilities. On the other hand, we have the impact of this digital technology on the economy and even society. Undoubtedly, BIM has all the hallmarks of innovation. Um, Finally, it allows us to model and simulate processes, not just objects. And finally, it is focused on remote teamwork and forces us to constantly increase the competences of our employees. When assessing the benefits of using the BIM methodology, we should look at the goals we would like to achieve thanks to it. This is one of the first steps in implementing BIM. Therefore, we must first define the goals that are to be the result of the implementation itself. It must be remembered that these goals and expectations do not have to concern only the ordering parties or investors, but also other participants of the investment process. Designers will have different expectations towards BIM and other contractors with their subcontractors or suppliers of materials and services as well. Let's look at the real example from the first BIM pilot project in infrastructure. This is a project of the bypass, small bypass of the town somewhere in the South Poland. Administration indicated areas where BIM should be delivered specific results. The first was standardization and quality. It was about the standardization of documentation markings, increasing the quality of the project, easier access to the results of acceptance, and qualitative tests. The second is increasing efficiency by eliminating paper correspondence and organizing electronic correspondence, but also reducing the time of the procedure. The use of 3D models for bills of quantities, cost estimates and schedules, collision analysis, communication with ordering party, technical meetings, reduction of the number of collisions with underground infrastructure, access to property data, and of course, reduction of paper documentation. The third concerns control and cost analysis. This is expected to improve the transparency of the evaluation of offers and the possibility of analyzing changes in geology. The fourth goal is better facility management. Optimizing design solutions should take into account the total costs, capex costs, analysis, and the use of 3D model for facility management. And on the fifth, there are fewer difficulties for the environment. It is about using 3D models and the GIS platform to assess the environmental impact of the works. Let's start with one of chosen goal, which is better management of the road or bridge. In fact, for every road administration, it is the most important task for which it was appointed. You can see that we have to completely change the way we described objects. Paper books, paper documents, and survey reports must be abandoned. And we should start building information models that will contain data only in digital form. I admit that I'm only a bridge engineer, and I'd like to apologize in advance if there will be more bridge examples than buildings. But I mean the same thing all the time. To change the description of building objects. This should be the starting point for linking the new guidelines for construction with BIM in the future. The answer may be the latest IFC standard, which also includes linear infrastructure facilities such as roads, railways, bridges, and tunnels. In the case of roads, it was crucial then that Building Smart, this organization, defined a class called IFC alignment that describes the axis of the road in the form of spatial curve. This class is also used when describing a bridge. This, however, must include a number of other, no longer road classes. You can see them here on our model of the Sant Kinga bridge in Stary Sącz. If we follow the requirements in the future, they will, they will definitely be in line with the BIM methodology. The phases of the life cycle of a construction object, where it can be a building, a highway, or a bridge, or a tunnel, follow the philosophy of sustainability and are described in the ISO standard 29481. And this graph is broadly consistent with this. So we have four phases, which include the planning of the facility and concepts, design, construction, use, operation, repeated maintenance, repair, and rehabilitation, as well as final demolition and disposal. BIM can be used in various models of construction, investment, implementation. And the traditional build approach, in which the employer orders the design documentation separately and then orders the construction of the facility separately on the basis of on this basis. The second, more and more frequently used model is design and build, in which the employer orders the documentation along with the entire construction process in one contract. This is also where the BIM methodology works. But we have the greatest expectations for the new integrated approach, which is possible only with the use of BIM methodology. It is about IPD, which means Integrated Project Delivery, which assumes close cooperation of all participants of the investment process. We'll talk about this in future lectures. In the BIM methodology, we have object-oriented IT tools that allow us to operate in virtual reality. So we do not draw lines and circles, agreeing with others that they mark, let's say, bearing us in this example, or column. Everything we design is visible on the structure of the entire model. The bearing, a bridge bearing, is represented by an object that has the bearing characteristics defined by the designer. And these parameters can be tracked and easily edited at the next stages of the life of the entire bridge. We can, for example, add information about the inspection or damage found to it during inspection. This allows us to create digital tools that will automatically generate parameterized BIM models of various objects. Here we see typical bridge structures described in the catalogue recommended by the Polish Minister of Infrastructure for use in the construction of smaller road bridges in Poland. If we are talking about small bridges and benefits, then look at how different technologies related to BIM can be integrated. Here the task was to replace the old bridge with a new one. It is a small bridge in Gliwice, very close to our university. Um, Soon there will be a quite a detour as the old bridge is being demolished. We performed the inventory works with the use of drones and the photogrammetry and laser scanning techniques. On this basis, we have prepared a BIM model of the existing facility, existing bridge, prepared for demolition, and a new already prefabricated bridge. Here we are already entering the construction phase. We can see now a virtual model of the development of the construction site, um, which is constructed for a concrete viaduct on traditional scaffoldings. In this way, we can predict the equipment of the entire construction site, the location of the warehouse, social space, and the machine park. We can define danger zones and restricted access. Simulating the movement and the impact of machines will allow us to choose their types, locations, and routes in the best way. For these, we can use virtual reality tools, commercial libraries of virtual objects for site planning are already being built. Now let's look at this short video sequence showing the organization of works and the movement of trains during the renovation of large railway bridge. Having a model of the entire construction, the entire structure, prepared in such a way and changing over time, we can create schedules in connection with the model, which is synchronized. So this is BIM 4D, which we have already talked about. Now, in turn, a fragment of the traditional bill of quantities of a bridge works, and here takeoffs related to the BIM 5D model. Automation and robotization, for example, earth-moving machines that can be controlled using a BIM 3D model. Construction meetings can be held with BIM 4D tools with visualization of the schedule and work performed. Supervision inspectors can use smartphones and tablets to supervise construction works, or even structure helmets with mixed reality goggles. And we already have very interesting support options with applications for tablets and smartphones. Here we can see a B model display module and with a augmented reality mode on the tablet. And now I'd like to discuss the CDE platform, Common Data Exchange. The basis for the success of construction investment is the involvement of all parties and the good cooperation in the implementation of the project objectives. Collaboration is not only about exchanging information on a regular basis, but also about understanding what happens to the information after it is provided. Today, this information must be readable and not only for people, but also usable um, in the devices they use. It is about structure, storage, format, and easy of access to data that must already be in digital form. Otherwise, it may cause delays due to the need of reprocess the data. It may also pose a risk of misinterpretation. According to the provisions of ISO 19650, in order to enable effective cooperation and access to generated information, it should be regularly made available to all project participants in a common data environment. A data exchange platform, sometimes referred to as a coordination platform, allows access to project documentation, including the B model, to all authorized process participants. Improve communication between them, of course. Here we have a symbolic representation of the CDE data exchange platform. Uh, Advanced platforms enable the automated flow of information and documents through dedicated commenting tools, approval taking into account roles, responsibilities, and etc. The CDE platforms ensure document and process management while maintaining the security of stored data. The CDE platform is usually specialized software that allows access to design documentation with BIM models to all authorized participants of the construction process and is used to improve communication between them. Access to data that is stored in one place, for example, on a dedicated server or in the cloud, is possible from various locations while maintaining full data security as well as control and granting the access level. The data can be documents, CAD or PDF drawings, forms, 3D models, and other type of electronic files. Version control is provided and user can view and tag files online without the need for native software. The circulation of information and documents is carried out by predefined methods of sharing, commenting, and accepting, taking into account the roles, responsibilities of users. CDE can take different forms depending on the size of or type of project. It can be a project server, extranet, or a cloud-based system. It is important that each team member has open and unlimited access to this digital space and that it can be easily divided into areas with different categories and information channels. It must be a common and well-managed space to share the effects of the work of the entire team. In the case of infrastructure projects, especially the so-called mega projects, one large CDE environment may turn out to be ineffective and difficult to manage. Such a situation took place, for example, during the implementation of the High-Speed 2 task in Great Britain. It was necessary to separate the cooperating CDE platforms. The project started with one environment, which was a very advanced platform, allowing the integration of 3D models. However, over time, the very complex and extensive model of the railway line being built became larger and larger and required more and more data transfers. Therefore, it was decided to separate GIS module from CDE, which was used to transfer simplified models intended for members of the project team with less IT knowledge and weaker computer hardware. These models contained only the necessary data, which were considered critical from the point of view of the formal requirements of the investment process, but without the high level of detail that designers of individual industries require. Thus, the concept of two CDE environments was created, which consists of three basic elements. Uh, First, a large CDE in the form of a simple and flexible platform with the possibility of introducing current changes to the program code. A small CDE in the form of a more complex and advanced platform, but with little possibility of modification. And a cross-platform data conversion and transfer tools. The data conversion process in this case consists in simplifying the BIM model that was created in a small CDE and in continuously feeding the data to a large CDE. Thanks to this, each user using a large CDE will be sure that design data is up to date. The role and potential of CDE have been recognized in, in the difficult situation in which designers and their offices found themselves as a result of the ongoing epidemic. After all, people talk about remote work many years ago. The internet and CAD techniques were supposed to be a way to lower the costs of running and design activity. Design offices would not have to rent and equip extensive office space often located in representative skyscrapers or metropolitan centers. The designer was to this home working, and to supervise this work, special tools were created to record employee time commitment and the results achieved. This type of service provision was actually provided only for programmers and the IT industry. In architecture and construction, despite better and better tools, it was still treated as a fad and obstacle. Suddenly, however, it turned out that due to the epidemic, overnight designers stopped coming to their offices and stayed at home. On the other hand, the owners and the management rushed to look for hardware and programming platform solutions that would enable the continued functioning of their enterprises and project teams. It may also turn out that after the successful extinction of the epidemic, all these rooms um, with equipment, furniture, social facilities, and archives will no longer be needed. Time will tell us. This concludes today's lecture, in which we introduced the BIM methodology. We discussed the maturity levels and compared CAD techniques with the BIM. We also discussed the benefits of using the BIM methodology and briefly the common data environment platform. Thank you very much for your attention, and I invite you to the next lectures in the BIM Basic series.